So hi guys.
It's me, Deepak, and like this is a new tutorial, new series where I'm gonna build reinforcement. I'm gonna build reinforcement models, and to start with, I'm gonna pick up pretty easy game, Flappy Bird. Although in this game the bird will not be flapping because I'm not gonna animate the flapping animation, but we're gonna make a custom environment for our for this project, and then we're gonna build a reinforcement. Then we're gonna use the reinforcement algorithm and see how well our bird can do, and if it can do anything or not. I mean, it can. I've tested it. Last time it stopped the program, it was around 13,500 something points. I have recorded footage of it. I let it ran the whole day. So without any further ado, uh, let's get started. Something wrong with my fan, I think. Yeah, it's pretty hot. Okay, it's running. So just to give you a heads up, you need assets for this project. So you can just check out my GitHub. I'll just give it this my GitHub link in the description for this project. You can download it and zip it, or you can just use git clone, and then you will be having these images. Only two images are required. So let's get started. First of all, I need a name for the script. Its name. Okay, and let me check something. Mm, 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 and, okay. So for starters, let me import few things. So for starters, we need Pygame to build our environment. I need time. I need random. To randomize the length of the distance between the pipe, and okay, for now that will do. I want to put TensorFlow, but it takes a lot of time if I need TensorFlow. You need few basic things to be installed, like Pygame, uh, Tensor. Those are long spelling. TensorFlow and something else. TF-Agent or something like that. So you need these things to be installed if you want to run this project. So just create a window for now. Um, we're gonna have a window of approximately 600 cross 800. So pygame dot display dot set mode and 600 800. If you remember, I previously also made Flappy Bird or copied the project from someone else previously, but this time I will do this without using someone else's code. Try to. I mean, the concept is pretty much the same. You need the bird to jump. Initially, the bird will have a rigid turning, so we need to increment its y position, keeping the x position same. So let's just import the images for bird and pipe first. So bird image dot transform dot uh, scale pygame dot image dot load, and the name is flapper.png. It's weird because bird will not be flapping. Although there is a way to make the board flap, and you just have to switch the image that you are rendering in the Pygame display. So you can set a timer. So when you press the spacebar for like 10 seconds, you can have for 2 seconds you will have the flapping image. Or when the acceleration is negative, you can have the board use different PNG and then different. And there is always a way to figure stuff out. Then I need a pipe image. We will be also we will have two pipes, top and bottom. So I'm going to use same pipe image, and then I'm going to flip one for top and other one will remain same. So let's have pygame dot image dot load, and it's pipe dot png, and okay, yep. We initialize fonts as well. So I'm gonna print on the screen high score as well as the current score that I'm playing. I'm just doing this when I'm the model I want to see, because I will be honest, I'm not getting like consistent scores on this model. Like one time I will get a 5 score 4,000, then next time 2,000, next time 0 in the same model, not even like training it. So I measure it down and I get like below it, but no. Pygame dot font dot init pygame dot font dot sys fonts. Sorry. And it's gonna be Comic Sans. We also need to convert this Pygame environment into TensorFlow environment, TensorFlow Pi environment. Although there are built-in environments, you can use OpenAI environment and convert it into TensorFlow Pi environment. But in this case, because it's a simple game, you can build around, and also because this environment is much easier than if you will use a easier to win the game. I mean, because you will see what I'm doing. So initially I will have a word class. I will pass the position for where to spawn the word. Seriously, what's wrong with this suggestions? Then I need self.velocity. This will be mostly negative. I'm going to compute the distance using s is equal to ut plus half at squared, as we used to in physics class. So that's why velocity is more. Initially, it's going to be 0, and every time I call a move function, I'm going to imply it. I'm going to return -5 every time. So 0 self.tick, which is our time, and every time I press a spacebar, this is going to be 0 again. So that okay, it's going to be 0. Let me just initialize it, and I will tell what I'm doing. Cell.height is equal to cell.y. This is not and score and high score. So every time I zero self dot high score is equal to 0. Now I need is a render function. I'm gonna pass the display as well here. Self, comma, window, and window dot bullet, and pass the body image, pass the position, so dot x, so dot y, jump function. So whenever I press spacebar, I mean AI is not going to press a spacebar, so we will have a different arrangement for that. I'll have a value between 0 to 1. So if it's less than 0.5, then you are not pressing spacebar, and if it's greater, then you are pressing the key. So then jump. So what I'm going to do, when I'm going to jump, I'm going to set dot tick equals 0, because you know half a t square. So every time t increases, the distance is going to be larger and larger, except for negative values of a. So if you know that y-axis is going downward, is increasing, not like in the first coordinate of first quarter of the Cartesian plane where y is increasing upwards. In this case, it's opposite. So self dot take is equal to 0, and we're gonna self dot velocity is equal to -10. Okay, and I'm gonna call the move function, pass self here. Every time I call the move function, I'm gonna increment tick by 1, and I'm gonna set, and then I'm gonna compute the displacement, and then I'm gonna, after computing the displacement, I will increment the y position. So what we're gonna do is self dot val into self dot take plus 1.5 into self dot take h power 2. So acceleration is 3 in this case. So that's why we are setting tick 2 like so that's why we are setting tick 0 when we jump, because even though cellular velocity is -10 when we jump, it's not going to make much difference when tick is far greater. So let's say tick is like, because we're calling it move function, we call in a while true loop almost like every frame, so that's not good. So we have to reset the tick to 0. Okay, now we have to set some bars. We can't have this be much greater than it should. So displacement is equal to 16 if it's greater than 16. So it won't the whatever you do, the jump won't be higher than 6, lower it won't I should say this, the fall won't be greater than pixels, and if displacement is less than 0, then displacement minus equal to. If self dot y less than 2, so in that case I won't be like going above the ceiling and equal to. Okay, then I have a mask function that will give me the mass of the bird so I can check for collisions. Yeah, I know, same thing I did last time as well. So only one way to figure out collisions is this, or a very weird log big O and square or n cube complexity algorithm that will figure out if they are colliding or not, which is a lot of work, honestly. So this is a better option. From surface, and I'm just going to pass the body image. Okay, Now we have set up the bird function. Let's just call our pipe. Now we have created a bird class. Now let's create a pipe class. So we have to have two pipes. They will be moving towards from y500 position. They will be moving towards y0. Also, I've set up a way that such that when they cross the bird by 30 pixels, they will disappear. So that I can focus on the next pipe for the algorithm's sake, not for my sake. That's one thing. Yeah, I know I read that in a blog. If you have read that in a blog and it sounds, or it just sounds like you have read somewhere, I have read it in a blog that doing this helps the algorithm get better if you can focus on the next pipe like this, because it is already passed almost. Then it doesn't need to be concerned about the pipe anymore and focus on the next pipe and make decision based on that pipe, like if I should jump or not. I feel like I'm missing something. Only 1 minute to figure out when I will run this. Self dot bottom equals 0. Self dot top equals 0. Now I need two images, as you remember. Pipe top equal Pygame dot transform dot flip. So the top pipe will be upside down. So the top of the pipe will be, you know what I mean, right? Pipe image false. Now let's set the bottom image. TTOM. It's going to be just pipe image. Now self dot passed. This is going to be boolean, which is going to tell if the pipe has passed or not. Self dot gap 300. So the distance between the pipe is going to be same, but where the pipes are going to be placed, that's going to be randomized. I finished circle here when I told you the gap is going to be randomized. No, it's where that gap will be, that's going to be randomized. Self dot, I'm just going to create a function height. Yep, so it's created. Set height self dot height is equal to random dot rand range 50 to 350. I'm going to have the top of the image is going to be self dot height minus self dot okay dot get height HEIGHT self dot bottom equal self dot height plus, so where the first pipe is gonna end plus the gap and then the bottom pipe will start. So that's one of the points here. So self dot gap render self comma when. Then we're gonna just have two of our pipes. Dot pipe top self dot x comma self dot top. Yeah, this should be in it. Yep. When dot split self dot pipe bottom self dot x self dot bottom a move function. So we have a self and self dot x and decremented by 5 Pygame, call it. Let's have a collision function now. If collision self bird. So we're gonna pass the object from our bird class so that I can call that get mask function. Now you will see why that's important. Bird dot get mask. Now I need top mask. Top mask, that means top pipe mask. Come on. Pygame dot mask dot some surface self dot pipe top bottom mask Pygame dot mask dot self dot pipe bottom. Need top offset self dot x minus go dot x comma self dot top minus round ball dot x ball dot y, sorry. Bottom offset equal self dot x minus self dot ball dot x and self dot bottom minus round ball dot y. Yeah. Now bottom points. So if any of the two values that are created returns true, then that means there's a collision. So if bird dot mask dot overlap bottom mask comma bottom offset or top points bird mask dot overlap top mask top offset if b point or c point return true, if not then returns false. Almost there, almost there. Now what we need to do is, I need to import few things now, first of all. So let me just have, you know what, let's just first check if the game is even working, otherwise it's gonna be weird. So let's have, I haven't get the clock variable, right? We'll just have a clock variable to drop the frames intentionally. Pygame dot. I need to see if the game is working. If then I can move to writing the reinforcement algorithm. While true, we can have for event in Pygame dot event dot get if event dot type equal to Pygame dot UIT, then Pygame dot quit and break. If event dot type equal to Pygame dot key down. If event dot key equal to Pygame dot k space, then RANG equal 1. Otherwise RANG equal 0. Okay. What am I doing here? Okay, yeah, right. Let's just create objects. Okay, I forgot I had to mention. But what I've done is I've created move function. I've called the render function for pipe and class. I created a list of pipe. Actually, what I'll do is whenever I cross a pipe, for the class issue, I will create another object. Um, so p if any of the pipes in the list returns true for the collision function, that means the bird has touched one of the pipes. So what I do is I have to break out of here. Okay. Then we have to add the pipes as well. Let's see if it runs or not. It's not gonna run. I'm gonna have lots of error. Okay, that's mm, load is not defined. Oh, comma there. Line 7. Bird is not defined, but I'm calling the birds. Random is not defined. Line 67. Collision signal requirement. It is PIRD. Bird object has no attribute mask. Line. Oh, here. Okay, I also forget to did one thing here. It's not gonna work unless I do that. That is the render functions need a display and also when dot fill and what? Okay. Oh yeah. Pygame dot display dot update. To update the display so something happened. What? Yep. I know. I think I do. Yep, here it is. Self.y plus equal displacement. It's too fast. So what I can do is I can have clock dot tick 30. No, shit. Mm, Okay, so now you can see I can create pipe, I can jump, and one more thing I want to see is, does the collision function work? Let's see. Collision function is not working. Why is that? Let me figure it out. 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 Okay. If Pedro is true, break. Nope. Something wrong here with the collision function. Ball dot get mass from sources amplifier bottom top minus that's not going to do anything, but worth a shot. Uh, so they don't know what's wrong. It's appeared to be fine. It's not. I can mass dot from surface board image. Board image. Okay, why isn't the collision function working? What's wrong here? What's wrong here? Bonus out of that top mask, top offset. Top minus round. What out y? What out y? What out get mask from surface, master surface, left on background, like whiteboard down. Everything seems to be fine. What's wrong? What's wrong? What's wrong? Hmm. Okay, collision function works. That means, I mean, if you want, I can just have print p dot collision board. True. Yep, it works. This works. I mean, so let me just comment this. You know what? Let's just comment almost everything out. Yep. Okay. Okay. So we are done with creating the environment. Now let's write our reinforcement algorithm. So we will import TensorFlow as TF. We will be needing NumPy as NP. Then I need to import a lot of stuff like TF agents dot environments import I environment. Just copy this. Let's see. Come on. Command C, Command V, and I need Py environment. I need TensorFlow, environment, and I need TF by environment. From TF agents dot specs import array specs for creating observation and action variables. I need this, and this is for converting the above ones, for converting our Pygame environment into the environment that TensorFlow can use for its reinforcement algorithm. From TF engines dot trajectories, this is used to store the state. We'll be creating a buffer, and we store the state, reward, and everything using trajectories. So this is what we needed. Import time step as TS. Then I need a few more things. You know what? From environments, I need to import utils. I need networks. Network. So from network, I need to import action distribution network, and this is for creating a neural network. We need to pass action. We need to pass action observe space, and left of thing I'm set to default except for iteration function, which I'm setting tanh. One more thing I need: TensorFlow agent replay buffer to store the buffer, to store create a set of and I'll be running episodes. That means instances of the game. Whenever I play a game, I will store how I played it. If it was better, positive rewards, negative. If it was bad, negative rewards. All those things in that happens in an episode, I'll be storing them in the replay buffer. Yes. So I need TensorFlow uniform replay VU. Anything else? Trajectories, I am storing environment trajectories, import trajectory, and utils. This was converting function graph. Common. This one is not important. Okay, now let's set few variables that I will be needing. Collect episode per iteration. You can do trial and error and see how it does. But I've seen that for first few hundred iterations, you might not get anything, or you may be lucky and you get in the first try a very good reinforcement algorithm and get very great reward. So like that, this can take like days to minutes to hours. It sort of depends on luck, on how network you get. Is it randomized and everything, and based on that, then you get a buffer. So every iteration, I collect 10 episodes, store in a replay buffer, and then I train the model on that, train my policy on that. Okay, now iteration 1000. Although I initially set it to 2000, but I couldn't train it for 2000. After 1000, it was released on a high score of 4000, 5000, something like that. So it takes that much time to run each episode, and then it gets slower and slower and slower. So yep. Okay, now let's create our environment. This is going to take some time. I mean, real time. So class Flappy Bird environment by environment dot envi environment. So we're gonna let's have the init function pass self. Let's create the object for our bird. Pass x and y. Self dot arrayspecs dot boundary boundary array spec shape. So action space will have a value between 0 to 1. So let's set the type to numpy dot float 32, minimum 0, maximum 1, comma name action. Then I need self dot observation spec. So I'm gonna pass 3 things here. So shape 3, numpy dot int redo and name observation. Yep. Self dot episode ended equal false. Self dot pipe list self dot pipe list dot append appended render self when dot fill 0, 255 0 for green color. Set the background self dot bar dot render. Call the render function here. Pass the window self dot for pipe in pipe list self dot render. Pass the display here. Now we need score here as well. So set the. This is going to be a long video, I think. Score label. Maybe set stat font. Render score. Plus str self dot dot score comma 1 comma 255 white color. When come on dot blade score label 600 minus label dot get UIDTH minus 400 comma 440. Yep. So this will display the score. Now I need to have high score as well. So same thing. Change this to high score label. HIGH high score dot HIGH high score, and let's set it to 8, and also Pygame dot display dot update. Now I need a reset function. So whenever I hit end episode, so whenever I hit the pipe, I will run this reset function, and what it does is it set the XM position of board to 300 400 as they were initially. It check if the new score is greater than the previous high score. If yes, then self dot board dot high score is equal to self dot board dot score. Self dot board dot score equal 0, and self dot pipe list equal this, and self dot pipe list dot append pipe 500. Yeah, and self dot current type step. So remember I said we need trajectories to store the state of the environment. Let's create the state when we reset the environment. So ts dot restart numpy dot array and self dot bird dot y. So y position of the bird, x position is always going to be same, that doesn't matter to us, and the distance between the top point and the bottom point. Self dot bird dot y minus self dot pipe list 0 dot height. This will give us the top position of the bird of the pipe, top pipe and the bottom coordinate. So let's suppose this these are two pipes and this is the board. So this will give us to this one, and the bottom one will give us to this one, the distance. So by subtracting the current by position of the board, you get how much distance is between the upper pipe and the lower pipe of the board. And self dot bird dot y minus self dot pipe list 0 dot bottom. Comma d type numpy dot nthird, and we will just return self dot current timestamp. Now let's have step function. To be honest, you have to have all these functions like render, run, render, step, and restart functions. You need this function, and as they are named, can't have them some other name. Won't work. Also action and resolutions back as well. So if action is 0.5 greater than 0.5, then self dot our birdie is gonna jump. For pipe in pipe list, the number of time I have to type self is directly proportional to my frustration level at this point. If pipe dot collision, pass our little body here as well. Self dot Episode ended. Yep. Also, if self dot episode ended, then self dot reset. Self dot move, and for pipe in self dot pipe list, pipe dot move if self dot pipe list 0 dot past equal to true, then I will eliminate that pipe list. Then I will eliminate that pipe equal none, and self dot pipe list is equal to self dot pipe list. If self dot pipe list 0 dot exposition, so if the exposition of the pipe is less than self dot bird dot x minus 40, and self dot past self dot pipe list 0 dot past equal false, then self dot pipe list 0 dot past equal true, self dot bird dot square plus equal 1, and self dot pipe list dot append pipe 700. Okay. So if if I have if the pipe is if the bird is not in the middle of the pipe, so I mean it's almost past the pipe, what I can do is I can focus on the next pipe. So I will create the next pipe, and I'm going to set the self dot this pass is equal to true, and when this is equal to true, I will just eliminate it here. So now it will focus on the next pipe. That's what I'm doing. And also that's one of the things I've said why this is pass is equal to false. Okay, now if length of self dot pipe list greater than equal to, then index is equal to 0 if self dot pipe list 0 dot past is equal to false, else, and this is only for one frame although, so focus on the next pipe, not the one that we have passed. So I have this index variable, else index is equal to 0. So if it's not less, so if it's only 1, then just index 1. So if self dot episode ended, then self dot episode ended equal false. So this is a reset, So I'll have a print statement here. It comes handy when debugging the code. Episode ended. Self dot current time step is equal to ts dot termination numpy dot array. This is going to be pretty similar to what we have here. So we just copy this list to save time. Okay. Okay, so I have passed the position of the birds, and then I need is dtype numpy in 32. There's something wrong here. Just can't seem to get it. Yeah, now it's fine. I was missing a comma. Also, reward minus 1000. So whenever episode ended means that I've hit the pipe. I have to tell that this is a wrong thing to do. So I'm giving it a reward of minus 1000. And this seems to work for me. Then just return self dot current time step. Now if not self dot episode ended, there are two things to do now. If self dot pipe list 0 dot pass. So this is only going to be one time thing. That's why I'm also resetting it after getting a post reward. What I do is, if it's true, that means I have just passed the pipe, so I have to give a post reward now. So let me just get this thing copy paste here. Okay, but instead of a negative reward, I will give a positive reward. Yes. And a discount. Okay. And if I haven't caused a pipe and I have just lived, then also I should tell it that living is also important. So else a small reward for the 1 and return current time step. The two more functions that I need: def action spec self here. Sorry, this is the function, and yeah, this is the hierarchy relation. And I will just, this function just do is return self dot action spec the other one. Let me see if it's in here. Yep. And I need same thing for my observations spec. Have your self, and this also will return relation spec. I said it once, I would say it again. Number of time to type self very proportional to the time I'm curious. Okay, so after creating this whole mess, now I can begin to write my reinforcement algorithm for my environment. But first of all, Py environment is equal to Flappy Bird environment, and then Py environment is equal to tf Py environment dot tf Py e and vir when t Py environment. Yes. And then have I written the clock somewhere here? Yes, here. So we're going to do noise. Have an actor network. Unity WRK. This will check that active distribution action distribution network, the active distribution. Okay, fine. Active distribution network environment dot observation spec Py environment dot action spec, and okay, there's one more issue that I get that I resolved through TensorSpec. So this is a data spec that I have to, this is the array spec that I have to transform to TensorSpec, otherwise I will get an error. Activation function equal TensorFlow dot keras dot activation dot damage. This will give you everything in the row. So optimizer, this also you can get through trial and error. figured out, for me the best was to have so dot compat dot v1 dot train dot Adam optimizer learning rate 0.001 and train step counter counter tf dot compat dot v2 dot variable 0 tf agent. So let's create our agent now, which is going to be an algorithm. So reinforce agent dot in force gent by environment dot time step spec. This will give you the current time step spec as that is the trajectory that we were doing. Tensor spec. Wait a minute. Spec dot from spec by environment dot action spec comma vector network equal vector net comma optimizer equal optimizer normalize returns equal true comma train step counter is our train step counter. Okay, fine. Okay, now we initialize our TF agent dot initialize. We have our evaluation policy POLICY TF agent dot policy POLICY and select policy. Select. This is used while collecting the dataset in a replay buffer. So what? Let's have our replay buffer. TF uniform replay buffer dot TF uniform replay BUFFER data spec equal TF agent dot collect data spec batch size equal environment dot batch size and max GTH is equal to 2000. Okay. Let's create an episode where I will let's create a function that will collect episode for me. Maybe ISO DE. I will pass here environment, PO policy, num episodes. Maybe yes. Then I have a episode counter initialize to 0. Then I have a environment dot reset. Then while episode counter there's a num episodes and step is equal to environment dot current time step action environment dot sorry. So based on our policy, we will take the action policy dot action. We pass it the time step and next time step is equal to environment dot step. We pass the action step here. Trajectory we'll get from trajectory from transition other time step action step and the next step, and then store it in a replay buffer dot add atch and pass the trash here. If trash dot is boundy episode counter plus equal okay, that will do it. I need to just check one more thing, just one more thing. Step. Yeah, fine. What if I got something? Okay, now last part. TensorFlow agent dot train equal common dot function agent dot train give agent train step counter dot assign for in range. So this will run for the number of iteration that I set initially somewhere here. uh, collect episode. We pass by environment here. df agent dot collect policy and collect episode for iteration. For that, experience equal replay buffers dot gather all. That train loss equal df agent dot train on experience. After that, I will clear the replay buffer dot clear step is equal to df agent dot train step counter dot numpy. If step modulus 25 print step equal loss equal dot format and step comma train loss dot loss. And after that, I will run a Py environment test is equal to Flappy Bird environment num time step is equal to Py environment dot reset Py environment test reset and while not time step dot is lost action step agent dot policy dot action time step I also need to and time step is a Py environment test dot step action step dot action and time test dot render. Now let's debug this. This will take like an hour or something to debug. Or am I kidding? Okay, first issue. Import libraries. This is gonna suck, man. This is gonna really suck. Tensor. Okay, this is only tensor spec. I didn't see the issue. Cannot import array specs from TensorFlow agent.specs. Okay, because it's array spec, and that means it's array spec here as well. Now what? Cannot import action distribution. It's actor distribution. It's bounded array spec. Actor distribution network is not defined. Line 247, 247. Okay. Reinforce agent is not defined. Yeah, where to import it from tf agents dot reinforce. Port reinforce agent. This should do it. The number of typos I'm making in this tutorial. Discount is there. Much. I'm a typo here as well. I think so. $232. There should be such an error. Its count is there. Oh, okay, shit. This is a transition. This control C control V thing is gonna not found, exotented. Couldn't ended. Why pipe list is not defined. What? Line 163. Now I know. 163. Self. This is a start. I still have, I don't know. There's a big road in, Another error. Now what? Let's put in a type for inf and Pygame.surface. I don't know. There shouldn't be such an error. But it is fine. Int for int and for operand type for int and Pygame.surface. Stat font. This issue there. What's this font? I should have checked fonts as well. I was initializing it, but why this error? I am not. Not sure. Once you say that's either it's stat font dot render. Another episode started. But what was the high score in that one? It's not like I'm running that much CPU power. Maybe I need to let's turn on the tab. Sure, dude, come on. Just stop. Okay, I got a score of 7. That means it's working. I need to just see it in action. Okay. Maybe I have done it, so you can like in the video. Okay, I score 1. And you can see after okay. Not that good, okay, not that good. Okay, 1. We can beat that? No, okay, so no, can't. But like you get my point, right? After a few of these iterations, if you keep running it, you will get something that can do decent. Won't say it's really good, but it will eventually be able to do it. Let's say end this video for now. I mean, if you really want to like interested in knowing, uh, here you can see it like got a score of 13,000 after I ended it. Yeah, it's like approximately that I ended it. So, and like it was a really good algorithm. Not algorithm, I mean luck or something. I get it this after like 100 something iterations. It does pretty good. So yeah, that's what I wanted to say. And like actually it's running still now. It doesn't like pause something. Yeah, actually I think I just so thank you for watching the video. Like the video, give it a thumbs up, subscribe, and stay tuned for more videos. Bye.